Hello everyone, welcome back to my channel. I am Disha of class 6 and today we are going to be learning about vectors of class 11 syllabus. So let's get started. So vector, first of all, before learning anything about vector, we have to learn where does it classify from. Means where did this vector came from? There would be a specific one, something that will be classified into dash and dash, right? Like this, it will be like that. So, vectors is classified from quantities. So, quantities are of two types. First of all, scalar quantity and vector quantity. Now let's learn something about scalar and vector also. As we are over here only, let's learn something also. So first of all, the main important point is, you may have heard that vector has a direction, specified direction. It has direction. But scalar has no direction. Example I'll give of scalar speed. If I say speed like 10 meter per second, speed 10 meter per second. So is it telling you in which direction you are going? We know that I'm traveling 10 meter per second, but in which direction? There are lots of directions, north, south, east, west, but in which direction we are traveling? So in speed, we do not get the direction. So that's why it is a scalar quantity. Now vector. Example of vector is velocity. Velocity. How? If I ask you the speed, you will just simply say 10 meter per second. But if I ask you the velocity, you will tell the direction also. Like 10 meter per second in north. I hope you are able to see this part of the board. Okay. So velocity example is 10 meter per second in north. And how do we represent vectors? How do we represent vectors? Okay. So we just write the symbol of the quantity in the vectors and we just put a left side arrow. Like velocity symbol is V. So we write V arrow is equals to 10 meter per second in north. Now let's learn one similarity and one difference. What is the similarity between them and what is the difference between them? So please take notes, handwritten notes yourself. You will be able to understand really quickly when you have exam or something. So similarity and difference. So similarity would be they both have magnitude. Scalar and vector quantity, they both have magnitude. Now what is magnitude? Magnitude is this word. No. What does magnitude mean? Magnitude mean value or constant. Constant you have learned, like the symbol which have a fixed value is called a constant. As I said, speed is equals to 10 meter per second. 10 is a constant, and in velocity I also gave 10 meter per second or 5 meter per second. Any constant you can take, but it should but both scalar and vector have magnitude. That is the similarity. But how can we find magnitude? It's some of you might have already understood how can we find magnitude. Like this is a vector. Okay, we have a vector. So the length of the vector is equals to the magnitude of the vector. Means the length of the vector means the magnitude of the vector. Same thing. Now what is the difference? Difference Can anybody guess the difference between them? We have already learned that scalar does have a specific direction, but a vector does not have a specified direction. Now, do you see this vector line? This vector line. So it has two parts. First of all, the end part or the last point is called the tail, and the arrow going part is called the head. These are the parts of the vector. Now let's learn types of vectors. Now this is going to be a long topic. Types of vectors. First, we have lots of types of vectors. We'll do pairwise. Now first we have equal and unequal vector. Equal and unequal vector. First of all we have unequal. We have 9 types of vectors. So first two are equal and unequal vectors. Equal. First two are absolutely very easy. This vector and this vector. They both have the magnitude same. Is same. A vector, B vector. A is equals to B by magnitude. By magnitude means the value is same. These are called equal vector. Unequal. Their magnitude is not same. Means A is not equals to B. Equal and unequal was really easy. Now parallel and anti-parallel. What is parallel and anti-parallel? Sorry, parallel and anti-parallel. Next pair we have is parallel and anti-parallel. Sorry. Okay. Parallel and anti-parallel. Parallel, I think you have learned already in class 5th or 4th. We have learned that parallel and intersecting line. Parallel and intersecting lines. So parallel are the lines that never means intersect or coincide with each other, and they go in a straight line forever. These lines are parallel. Okay, these lines are parallel. But these two lines are not parallel. You're thinking, why? Because these two lines are not concerned, means intersecting with each other. But why these are not parallel? So you have to think. You see this arrow? In this side also. You see this arrow? Means it goes infinitely in both the direction, right? So, if I extend both this sides lines, it will be parallel forever, right? But if about this, they will go in again straight line, and at some point they will go and coincide with each other, so they are intersecting lines also. Parallel vectors I have just given. Parallel vectors like this, just a ray. And angle between parallel vectors. Angle is 0 degree. In parallel angle is 0 degree. But if we're talking about, when we are talking about anti-parallel, you're thinking anti-parallel is like intersecting? No. It is parallel only as it has the word parallel in it. But anti-parallel, they both go in different directions. Means they are parallel, but they both go in different direction. Like this vector is going on the right side, this is going on the left side. Okay, and the angle between these is 180 degree. So next pair Next, we do not have a pair, so we'll do one by one. Next, we have collinear. Collinear. Have you learned in physics or in science, if you are in 4th class, that light travels in a straight line, and that property is known as rectilinear propagation of light. Rectilinear and rectilinear propagation of light. You may have heard linear, rectilinear. Listen, rectilinear. Rectilinear means in a straight line. It has the word linear in it. Linear also means straight line. Okay. What was the topic? Collinear. Collinear means they're not collinear. Means they don't go in a straight line. If you're thinking like this, the vectors are going in a straight line. These are collinear, no? These are parallel, right? Means it could be 2 or more type, but still, this is not collinear. Collinear, the vectors are going in a straight line. 2 or more vectors are going in a straight line. This is called collinear vectors. Next, we have coplanar vectors. There is an interesting thing about coplanar vectors. Coplanar. So, the vectors which lie on the same plane. This is the plane. Wait, I'll give an example. The vectors which lie on a same plane. Imagine these are 2 vectors. Okay. If we look, this is a plane. They lie on the same plane, right? But there is an interesting factor also about this. What? Any two vectors are always coplanar. If we take any 2 vectors, they will always be coplanar. Means they will lie always on the same line. Sorry about the red thing. Like I have 2 vectors. Imagine this is the vector. This is the head. The arrow going part is known as the head of the line. Wait. This is known as the head, and this is known as the tail. So imagine the marker tip is the head. It is acting from the same point. 2 vectors. Okay. Do they lie on the same plane? Yes. You can take in any way. They will always lie on the same plane. But if you're talking about 3 vectors may or may not be coplanar. They may or may not be coplanar. Like I have 3 vectors. They are on the same plane. But what about this example? Wait. But what about this example? 2 vectors coplanar, 1 vector on the top. Is this coplanar? Wait. Is this coplanar? No. These 2 lie on the same plane. These 2 lie on the same plane. These 2 lie on the same plane. What? Not all. But if we are talking about this straight, they all lie on the same plane. So any 3 vectors may or may not lie on the same plane. Next, we have concurrent. We have concurrent vectors. Concurrent. So as I give you the example of concurrent. As I give you the example of 3 vectors, right? What they were going from the same point. This was the point. 1 vector was going over here, 1 vector was going there, 1 vector was going there, right? So the vectors which act on the same points, means which start on the same point, are called concurrent vectors. Next, we have the last 2, that is unit and zero. Sorry, 0 and unit. 0. It's really easy. When the magnitude is 0. Next we have unit. What is unit vector? Unit vector. When the value and magnitude means both this mean the same thing. Means when the magnitude is 1, it is called a unit vector. Okay. Example, like I go from Delhi to let's take an example, Kota. I go from Delhi to Kota. So it is an example of what? Unit vector. Next we will learn the most important thing and the most fun part for me also, and I hope it will be fun for you. Parallel shift of vectors. This topic is the most fun. Like, it's really fun to shift the vectors and find out the angles between them. Do you know the angles? In parallel shift of vectors, the main angle that is important is straight angle. This is a straight angle. This is a straight angle. This is a straight angle. 180 degree. Straight angle is equals to 180 degree. So parallel shift of vectors. How can we do parallel shift of vectors? First of all, let me get the heading. Parallel How can we do parallel shift of vector? When we connect tail to tail. How can we do parallel shift of vectors? When we connect tail to tail or head to. Parallel shift of vector is possible when we connect tail to tail or head to head. Like, can I give an example? This is not an example of parallel shifting. 90 degree. Wait. You have to find the angle. Actually, it is already connected tail to tail. So no need, means we can find out the angle when it is the 1/4, right, of the circle. So it's 90 degree. Please, so next example, let me take. Okay, got it. Wait 1 second. I just have to think of an example. Got it. First of all, let me draw. Okay. Imagine we have a vector A. Wait, let me draw it bigger. A and B. I have a vector, A and B. It is connected tail to head. This angle is 120 degree. I know this is a 90 degree angle. Okay. So, I told you to parallel shift of vectors. So, I could just shift this as it's going there to their side. So, I could just shift this line above. Now it is connected tail to tail. This is the head. Right? Now what will be the angle? As it's a plane, means it is a straight line. Straight line is equals to 180 degree. Next, 180 degree minus 120 degree is equals to 60 degree, means this angle is equals to 60 degree. Hope you got it. So next example, now it's like not hard but very easy. It is like very fun to shift the vectors, right? Okay. This is a vector. This is a same plane. Okay. A line, actually 180 degree one. This is vector B. C, D. This is equal to 60 degree. This is equal to 30 degree. Do parallel shift of vectors, like find the angle of AB, AC, AD, BC, BD. Find the angles of these vectors. Okay. So how we'll find out? We'll just do parallel shift of vectors. So what if, everyone, I'm drawing this over here, okay? So I shift this A line onto the right side of the plane. Is it visible, guys? Okay, yes, it's visible. This part is much more visible than that. Okay, so I have this A vector and I shift it towards the right side of the plane. B vector straight goes like this. C and D same. Now can we find? Yes, all are connected tail to tail. That's great. Now let's find the angle of AB. AB. This is half angle. As the straight line is there 180 degree, this is half of that 90 degree, and 90 degree plus 130 is equals to 120 degree. AC. From here or from there? Okay, from here only. So 30 degree plane, 60 degree plus 30 degree, 90 degree, 180 degree minus 90 degree is equals to 90 degree. So 30 plus 90 is equals to 30 plus 90, 120 only. AD. 30 degree. BC. 60 plus 90, 150. BD. 90 plus 30, 120 degree. So, yes. Next we have a really short topic. It's not even a topic. It is vector commutative. In schools, you may have learned the commutative property of addition and multiplication. Now, the question raises, is vector commutative? Is vector commutative? Means if we are plussing two vectors, magnitude means the value we are plussing. Two vectors magnitude we are plussing. Will it be equal? Like A vector plus B vector is it equal to B vector plus A vector? Absolutely, because commutative addition satisfies the commutative property. So, is vector commutative? Yes, it is absolutely commutative. So everyone, that's all for today's video. I hope you like this video and you understood everything. If you can't understood anything or I have made a mistake in the video, please let me know in the comments. That way I will learn also. And hope to see you in the next video soon. And if you want to give more topics, please give in the comment section. I will help with your exam and it will help me also to learn more new things. And thank you, absolutely. Thank you, take care, and bye bye. Stay safe.